It is Christmas break right now, and here I sit in my classroom making videos for you. But that's okay because I'm a big believer of using the time when you have it to use. Today we're going to be working on Module 8, Lesson 2, which involves the slope of the line. Slope of the line is a huge concept, and you're going to be doing all kinds of stuff with this as you go through algebra on up into high school. According to our pacing guide, they're claiming this is going to be a 2-day lesson. So let's get into it. Looks like we have 25 resources to get through, and that's quite a bit. One of the tallest roller coasters in the United States is the Millennium Force. Located in Ohio, passengers on this steel roller coaster experience speeds up to 93 miles per hour and a 300-foot drop. There is no way you would ever get me on that roller coaster. Not gonna happen. I don't do swing sets. I sure the heck ain't gonna do that roller coaster. Anyhow, a ride at an amusement park rises 8 feet for every horizontal change of 2 feet. What are some ways that you can describe the steepness of this ride? Well, that's what the study of slope is all about. Our inquiry question asks, how can you demonstrate the concept of slope as you travel from one point to another point on the coordinate plane? To study that, we're going to take a look at this chart where we have the start point down here, we have the target point down here. And currently this one is set up with a vertical change of 1 and a horizontal change of 1. And we would also refer to vertical is rise and horizontal is run. But I'm getting ahead of myself. If I was to take a step, you can see it would go rise 1, run 1, rise 1, run 1, rise 1, run 1, and it would keep doing that pattern all the way until it hit to the target. And it's the same exact slope all the way across to get to where it's going. So here you would, no matter which 2 points of the line you took along this way, yes, we have these two at the beginning and end, but that's a point, and that's a point, and that's a point. Anywhere along here is a point that makes a straight line going to that destination. Now, let's reset this, and let's go for a vertical change of 2. And let's see what happens. Now we're going to rise 2 and run 1, rise 2 and run 1, rise 2 and run 1. Well, we're missing our target, that's for sure, so let me do something different. Let me take and reset this again, and we're going to change this to a vertical change of 2 as well. And now what's going to happen? Rise 2, run 2, rise 2, run 2, rise 2, run 2. We get to our target again. The point being, for this particular graph, your rise and your run has to be the same, but whether you do 1 and 1 or 2 and 2, what's 2 divided by 2 equal? It equals 1. What's 1 divided by 1 equal? It equals 1. So your slope for that problem would be 1. Don't stress it. We're going to talk more about this. But what if instead we use these 2 points? Now you can take and see that if we were to take and do the rise 1, run 1 all the way across, we're going to end up not hitting our target. So we need to come up with a different pattern. To help us come up with that pattern, I'm going to reset here, and I'm going to show the line that connects between the 2 points. And I want to take and find what 2 points I could do that's going to get me to where I want to be. And let's see, that doesn't intersect that one. That one's close, but nope, nope, nope. About the only thing I can see that's going to get me where I need to do is if I do a vertical change of 7 and if I do a horizontal change of 5. That's going to be one big honking step. Now if I was to take that step right there, rise 7 and run 5, that would end up getting us to our destination. That would be the slope. The slope of that line would be 7 over 5. Rise over run. It really is that simple doing slope. And that leads us into some definitions here. So let's take and zoom in a little bit. The term slope is used to describe the steepness of the line. While they don't have that tagged as a definition, it is pretty darn important. The slope is the rate of change between any 2 points on the line. The vertical change, also known as the change in y value, is called the rise, and I told you that just a little bit ago. Meanwhile, the horizontal change, also known in the as a change in your x value, that is going to be called your run. So you picked up two definitions there. The slope is going to be the ratio of the rise to the run. So here you can see they've got in the formula, slope is equal to rise over run, where rise is going to be the vertical change between any 2 points, and the run is going to be the horizontal change of any 2 points. You will need to write this formula a lot on your homework tonight for all the problems it applies to, but you don't have to write all this many words portion. All you have to do is write slope equals rise divided by run. It's that simple. Now we do need to point out that a slope can be negative as well. We're going to highlight that as important. The slope of a line that points upwards from left to right, that's going to be a positive slope. But if it goes down from left to right, that's going to end up being a negative slope. So let's take a look at this in words here. The positive slope is going to look something like this, where it goes from the lower left to the upper right. Meanwhile, a negative slope is going to look something like this, where it goes from the upper left to the lower right. A positive slope, moving left to right, you have to go up a hill. A negative slope, going left to right, you have to go down a hill. That's all there is to it. Now, as we talked about before, the formula for slope is equal to rise over the run, and the slope can be found from a graph by finding that ratio of rise to run between any 2 points. It does not matter what 2 points you use. Remember when we did the 1 to 1, it gave me a slope of 1, and when I did the 2 to 2, it still simplified. 2 divided by 2 gave me a slope of 1. So right here, we've got 2 points. The first point is going to be at negative 2, 1. The second point is going to be at positive 2, positive 2. Now it says when reading rise and run from a graph, your rise up is positive and rise down is considered a negative. A rise to the right is considered to be positive, and a rise to the left, or a run to the right is positive, and a run to the left is going to be negative. So for this one, we're going to rise 1, 2, 3, and we're going to run 1, 2, 3, 4 to get to the points. And if you look over here in the really fine, too far, print right there, it shows you that the rise divided by the run, that is equal to 3 divided by 4. So the slope of that line is going to be 3 to 4. Now this graph is sharing how much the cost of muffins are at a bake sale. And you can see you have a graph that travels from point 24 right here to point 36 right here. And it wants to know what's the vertical rise going to be. Well, the vertical rise is going to be 1, 2. So our rise is going to be 2. Let's see if they're going to give a spot to put there. Nope, they did put it right there. Meanwhile, the run is going to be 1. So we rise 2 and run 1. That gave us a rise over run here of being 2 over 1, and 2 divided by 1 is 2. So our slope for that line is going to be 2. It's that simple to find the slope of these lines when you're just looking at 2 points like this. Now I did just see on the graph, we can take and put the rise, and you see it just showed the rise right here. And I'm going to press the run button, and it showed the run right here. So your rise was 2 and your run was 1. Now how can we tell that that graph is going to be positive? Well, the math told us it was going to be positive, but if we just look at it from the left to the right, you're going uphill. That means it's going to be a positive graph. Now you take a minute, pause the video, and work on this problem where you're going to find the slope of this line. Now, of course, the first thing we have to write is a formula, and I'll give you a little tip here. You don't even have to write the whole word slope. You can just write M, because M is the universal definition or indicator for slope. So I wrote M is equal to rise divided by run, which is equal to, well, my rise, I'm going to rise 1, 2, 3. So I have 3 over 1, and of course 3 over 1, that's just going to equal to 3. So the slope of this line is going to be, let's find it right here. We're going to put, they want us to use a fancy box there, so it's going to be 3 over 1, also known as just 3. Check our answer. That's all there is to do in this problem. So what if we were graphing how much water is contained in a bucket of water that was leaking? Well, the volume of the water would be going down, and that would be giving us a negative graph like you can see here. And they've given us these 2 points where you've got 0.35 and 0.91. Now, if we were to take, and are they going to give me the rise and run buttons? Yep, the rise, you can see, is going to be a -4 because we went down 1, 2, 3, 4, and then we ran to the right 6 spaces right here. So you have the rise over run that wrote the formula first. Then they plugged in the -4 divided by 6, and that in simplest terms is going to be a slope of a negative fraction 2/3, because we always simplify our fractions. Check your answer. The answer checks. That's all there is to doing this. And once again, you're going to get a chance. Pause the video and work extra example 2 on your own. Now once again, the first thing we have to do is come up with a formula, and our formula is going to be slope is equal to rise divided by run. Where this time we're going to have a negative rise because we're going to go down 1, 2 spaces. That's going to give me a -2 over a run of 1, 2, 3, 4, 5, 6. So I get a -2/6, which is also known as a -1/3 for your final answer. Jump back over to our textbook, which is right here, and we're going to take and type in our negative fraction bar, 1/3 for a -1/3. Check it, and everything's good. Now so far we've looked at how to find the slope by just looking at the change in values on a graph. We can also find the slope by looking at the change of values on a table. And you can see that on this table here it shows that the x, remember your x is your horizontal, your x is your run, so these are written kind of backwards. But your x is increasing at a constant rate of 3, while your y value is decreasing at a constant rate of 30. That means that in our formula where we take and write down what the slope is equal to, the rise is going to be the -30 divided by the run of -3. That gives you a slope of -10/1, which you could also write as being just a -10. For example 3, they've given us a table. Remember, your x values are your horizontals, your y values are your verticals. That means x is your run, y is going to be your rise. And if you take a look at that table, you're going to see that there is going to be some constant rate of change there. Looks like they're not going to show it all to us nice and pretty here. No, they're not. So let's take and just jump over and get a screenshot of that. I missed the fact that for this one, they totally threw us another loop. They're using a different formula. And if you take a look at that formula, scroll into it, instead of being rise over run, they wrote it as a change of y minus or divided by the change in x. And working that problem, they ended up saying the change in y was -1 minus a -2. Where on earth did all that come from? Well, let's take a look here. Jump back to the table. The -1 is going to be this value, so they're focusing entirely on these two terms right here, keeping it kind of simple. So the -1 is right here, minus the -2 is right here, and that is where they got these values for the change in y from. Now if we take a look at the x values there, you have a -2 minus a -6, because you remember the change, there's a difference there, so we're going to be doing subtraction, and that's where they get the -2 minus the -6 from. Now if it was me doing this problem, I would take and make the ugly problem for pretty first, because it looks mighty confusing having a minus and negative there. So I would take and write a brand new line that would say -1, a negative times a negative is going to be a +2 divided by a -2, and a negative minus or times a negative is going to be a +6. From there we get to say signs are different, find the difference. So the difference between 1 and 2 is going to be 1. with a sign in front of a larger number going in front of your answer, making that a positive 1. And then the difference between negative 2 and 6, that's going to end up becoming 4, once again, with a sign in front of a larger number going in front of your answer. That's going to give you a slope of 1/4. Now, if we were to take and jump back over here to the textbook, you can see that they just went boom, 1/4 without making the ugly problem pretty. Don't do that. You're going to make mistakes. And from there, of course, you could take and type in the 1/4 for your answer, but why bother? They gave it to you right here. Now you take a minute and work this problem using that formula, change in y divided by the change in x. Remember that you can take and use any 2 points on that graph. If it was me, I'd use the first pair of points because that gives me the smallest, easiest numbers to work with. How'd you do? Here I go. So I've got the change in y, so I'm going to minus the change in x. So I'm going to take and use these 2 points, that one and that one. My y value goes from 12 to 9. So that means that my slope is going to equal to, do the second value first, 9 minus your first value, because that's going to be your change. And then from there, my x, I'm going to do my second value first, 3 minus 1. From here, I can take and say 9 minus 12. Signs are different. Find the difference with the sign from your larger number going in front of your answer. 3 minus 1, that's just going to be a 2. So my answer, the slope, which we actually get to leave as an improper fraction. You never change slope into a mixed number. You can leave it as an improper fraction. Isn't that wonderful news? So from here, we're going to jump back over, type in the slope of a negative fraction, 3 divided by 2, accept and check, and the answer checks. This is where we're going to end part 1 of this video. Come back and watch part 2 in just a little bit to learn more about this.